First example, PT NH3 twice Cl NO2. Here NH3 is the ligand, its name is amine. Chlorine, Cl is the another ligand. When it acts as a ligand, its name is chlorido. NO2 is called nitrito N. Actually, it is an ambidentate ligand. When it acts as when it comes in NO2 form, it is called nitrito N. If in any of the complex, if it is comes in ONO form, it is also called nitrito, but we have to use the word nitrito O. Now we have to write the name, that is 2 times amine ligand repeating, so diamine, chlorido, nitrito N, platinum. Now we have to calculate the oxidation number. For platinum X, amine is a neutral ligand, so charge 0. Chloride -1, nitrito also -1. So X equal to +2. So the name is diamine, chlorido, nitrito N, platinum 2. Next, we are going to write the IUPAC name of K3CrC2O4 thrice. So as usual, first we have to write the name of the cation. Name of the cation means potassium. So we write potassium. Now we have to write the name of the anion part. Anion is a coordination entity. So we have to use the rules and regulation. As per the rules, first we have to write the name of the ligand. Which is the ligand present here? C2O4. That C2O4 is called oxalato. Actually, it is an oxalate ion. When it acts as a ligand, it is called oxalato. So now we have to write that oxalato. Repeat for 3 times. So trioxalato. Now we have to write the name of the central metal atom. We know chromium is the central metal atom. As we have to write the name of the chromium as a anionic part, the name of the central metal atom should end with ATE8. So we have to write chromate. Now we have to find out the oxidation number. For potassium, 1 potassium plus 1. 3 potassiums are there, plus 3. For chromium, we have to calculate, so X. Oxalate, 1 oxalate minus 2 is the charge. So minus 2 into 3 minus 6 equal to, no charge is given, so 0. That means X equal to plus 3. So potassium trioxalato chromate 3. Next we have to write the name of the complex CO Cl2 En twice square bracket Cl. For writing the name, as usual, since it is the first we have to write the name of the cation. Cation is the coordination part, so we have to first write the name of the ligand. Here one ligand is Cl, you know the name, that is called chlorido, CHLORIDO, chlorido. Another one ligand is En. En means it is called ethane 1,2 diamine. Ethane 1,2 diamine. These are the ligand. First, as per our usual rule, C will come first in alphabetical order. So we have to write 2 times it is repeating. So dichlorido, CHLO, chlorido, RIDO, chlorido. Now ethane 1,2 diamine is repeating 2 times. So you have to write ethane 1,2 diamine. But the problem is, if the name itself having di, the ethane 1,2 means it is the name. Inside the name we are having the name di, tri, tetra, etc. like that. If such word is present inside the name of the ligand, then the repetition of particular ligand is represented by the word bis, tris. If it is repeating 3 times, you have to use the word tris. If it is repeating 4 times, then we are using tetrakis. If it is repeating 5 times, we have to use the word pentakis. Like that, we have to use. So, this is not correct. So, how we got to write? Diamine. Dichlorido, CHLORIDO, dichlorido, bis. Because ethane 1,2 diamine repeats 2 times. So the repetition is represented by the word bis. After writing bis, put a small bracket. Inside the bracket, you have to write ethane 1,2 diamine. Now close the bracket. Now you have to write the name of the central metal atom. Which is the central metal atom? Cobalt. Since it is the central metal atom of a cationic part, its usual name is given, that is cobalt. After writing the central metal atom, we have to find out the oxidation number. For calculating oxidation number, for cobalt, we have to calculate, so X. For 1 chlorine minus 1, so minus 2. 2 chlorine is there, so minus 2. Ethane 1,2 diamine is a neutral ligand, so plus 0. Then 1 chlorine is present outside as a counterpart, for that minus 1 equal to 0. So X minus 3 equal to 0, that is X equal to plus 3. That means cobalt, in a bracket you have to write the oxidation number 3. Now we have to write the name of this Cl. Cl, when it comes as a counterpart, its name is chloride, CHLORID, chloride. So dichlorido bis ethane 1,2 diamine cobalt 3 chloride. Dichlorido bis ethane 1,2 diamine cobalt 3 chloride. Next example, CONH3 5 times CO3 Cl. So as usual, here one ligand is NH3. It is called amine, a double M. Don't forget. The next ligand is CO3. CO3 means it is actually carbonate ion. Carbonate. So when carbonate ion acts as a ligand, it is called carbonato. Carbonate ion, when acts as a ligand, its name is carbonato. Now write the name. 5 times amine ligand repeating, so pentamine carbonato. Now we have to write the name of the central metal atom of cationic part, so you have to use the same word, cobalt. Now find out the oxidation number. For cobalt we have to write X. Amine, already we studied, it is a neutral ligand, so the charge is 0. Carbonate ion formula CO3 2 minus, so the charge is minus 2. So for one carbonate ion, minus 2 is the charge. For chlorine, already we discussed, that is minus 1. So X minus 3 equal to 0, X equal to plus 3. So cobalt 3. Now we have to write the name of this Cl, that is chloride. So the name is pentamine carbonato cobalt 3 chloride. Next, we have to write the name of HgCOSCN 4 times. Here, the ligand present is SCN. SCN, when act as a ligand, it is called thiocyanato. This thiocyanato is an ambidentate ligand. So, in some coordination compound, in some example, it may be written as NCS. If it is written as NCS, then its name is isothiocyanato. Be careful about this. if we are writing this as SCN, we have to call it as thiocyanato. If it is written in the question as NCS, then it is called isothiocyanato. Now, this is the complex, SCN is there, so the name is thiocyanato. Now, we start write the name. First, as a cationic part, mercury is present, so we have to use mercury. 4 times thiocyanato ligand is repeating. So, tetra thiocyanato. Now, we have to write the name of the central metal atom. Central metal atom is cobalt, but it is the central metal atom of anionic part. So, it name end with the ATE. So, the name is cobaltate. Now, we have to calculate the oxidation number for mercury +1. For cobalt, we have to calculate, so X. SCN, for 1 SCN, -1 is the charge. 4 SCN is present, so -4 equal to 0. X minus 3 equal to 0, X equal to +3. Therefore, mercury tetrathiocyanato cobaltate 3. CO NH3 4 times, H2O Cl Cl2. So, as usual, we have to write the name of the ligand first. So, NH3 we know amine, Cl we know chlorido, water. But when H2O act as a ligand, it is called aqua. So, now we have to use the alphabetical order. Alphabetical order AM. Here AUQ. So, AM will come first. So, tetramine. See that we are considering alphabetical order. But we are writing T. This T, tetra means it is indicating the repetition. So, while considering alphabetical order, the repetition prefixes are not considered. Only the name of the ligand is considered. So, tetra we are not considering, only amine we are considering. So, amine will come first. So, tetramine. Now, instead of water, what you have to write? Aqua, chlorido, cobalt. Because it is the central metal atom of cationic part, so there is no need for ATE. So, cobalt. Now, we have to calculate the oxidation number. For calculating oxidation number of cobalt, X. Amine is a neutral ligand, so its charge is 0. Water is also a neutral ligand, so its charge is 0. For 1 chlorine, -1. For 2 chlorine outside, -2. So, X minus 3 equal to 0, X equal to +3. So, then cobalt 3. Now, we have to write this Cl as chloride. Tetramine, aqua, chlorido, cobalt 3 chloride. Here 2 times chlorine is there, but that too we are considering for calculating oxidation number. There is no need to write the 2 here. So, tetramine, aqua, chlorido, cobalt 3 chloride. Now, we are going to study about the next example. PT NH3 twice Cl, NH2 CH3 Cl. Here, as usual, NH3 is a ligand, it's called amine. Cl is another ligand, it is called chlorido. NH2CH3 is given. The name is methanamine. The name of NH2CH3 is methanamine. Methanamine and amine are neutral ligand, so the charge is 0. Whereas chlorido is a negative ligand, -1 is the charge. Now, we start write the name. Alphabetical order, while we are following alphabetical order, amine will come first. So, 2 times it is repeating, diamine, chlorido, methanamine. Now, we have to write the name of the central metal atom, that is platinum. Is a cationic part, so platinum. Now, we have to calculate the oxidation number for platinum, X. Ammonia is a neutral ligand, so 0. Chlorine -1. Methanamine is again neutral ligand, so 0. 1 chlorine is present outside, so -1. So, X minus 2 equal to 0, that is X equal to +2. So, platinum 2, Cl is present, so chloride. So, the name is diamine chloridomethanamine, platinum 2 chloride. IUPAC nomenclature we are now discussing. It's a very important one for the board exam. One question is sure, but sometimes they will given the name like this. IUPAC name potassium tetrahydroxidosincate 2. For that we have to write the formula. That means we have to write the reverse. Up to this what we write, for the formula we write the name, but now name is given. For that we have to write the formula. For that what we have to do, potassium tetrahydroxidosincate. So potassium is given, so we can write potassium. Hydroxido means OH. Tetra, that is 4 times. Now cincate, that means cincate is the central metal atom. This is the outline. Now the charge is given as 2. For the zinc, 2 wants to come. For that what you have to do, just to see for the square bracket, inside the square bracket zinc it is given 2 plus 2. OH, we know minus 1 is the charge, 4 times, so minus 4. This is the charge inside. So we have to calculate what is the charge given for potassium. So inside if you solve it, what will get? Plus 2, that is minus 2 will comes. So if we are giving plus 2 outside, then plus 2 minus 2 will become 0, because the total charge is equal to 0. Here no nothing is given, so 0. So what we have to do, K2 Zn OH 4 times. If you write, now you calculate for zinc how many charge, what about the charge for zinc? Plus 2 plus x minus 4 equal to 0, that is automatically we will get 2. Plus 2 will come, that is this 2 will come. So the formula, correct formula of this complex is K2 Zn OH 4 times. Like that, for each compound you have to practice.